Welcome to This Explainer. Today, we're bringing absolute focus to a critical, yet often totally overlooked area of science, nutrient management in urban agriculture. We walk past community gardens and rooftop farms all the time, right? But what exactly is it going to take to turn a patch of concrete jungle into a thriving, high-yield food source? Well, that is exactly what we're going to unpack today using some genuinely fascinating new research. So here's the big question. Is urban farming the definitive answer to food security in densely populated areas like Malaysia's Klang Valley? It's a hugely pressing challenge. We have an urgent, undeniable need for resilient urban food systems to feed our growing populations. But we're instantly hit with a massive reality check. Limited agricultural land and massive space restrictions. How in the world do we maximize crop growth when we're literally running out of room to grow it? Here's our roadmap for today. 1. Malaysia's urban farming boom. 2. The Great Fertilizer Showdown. 3. The Fast Fix. 4. The Slow Burn. 5. The Soil Health Battle. And 6. The Ultimate Winning Combo. Let's dive right in. Section 1. Malaysia's urban farming boom. Growing food where space is tight. Look, all this enthusiasm for urban farming hits a wall of physics and biology pretty fast. Space? Severely limited. And the urban soil quality? It is notoriously poor, often compacted and completely stripped of natural nutrients. That means nutrient management becomes the ultimate bottleneck. If we want to make these tiny urban spaces highly productive, recent studies emphasize that we absolutely must close nutrient cycles using sustainable fertilization. You can't just toss a seed on a concrete lot and hope for the best. You've got to actively manage the science of the soil. Moving to Section 2, the Great Fertilizer Showdown, chemical versus natural. In one corner, we have inorganic fertilizers, specifically NPK. These are chemically manufactured and designed for a sudden, massive jolt of rapid plant uptake. And in the other corner, organic amendments, like biochar and chicken manure. These are naturally derived materials that release their nutrients way more gradually. So it's a classic heavyweight battle, rapid chemical delivery versus gradual natural release. Section 3, the Fast Fix, NPK, basically the sprinter. NPK's absolute superpower is rapid nutrient availability. The nitrogen drives leaf and stem development, the phosphorus fuels root growth, and the potassium boosts overall plant vigor. When you apply NPK, bam, you get immediate biomass accumulation. Plant height shoots up, leaves develop fast, and nutrient deficiencies are corrected almost overnight. For an urban farmer trying to quickly churn out short-cycle vegetable crops like microgreens or lettuce, NPK acts as an absolutely crucial fast fix. But here's the catch. Prolonged use of these chemical fertilizers leads to soil acidification and declining microbial activity. We're impartially looking at the data here, and the research shows that excessive continuous dependence on NPK can literally degrade your soil structure over time. The soil's long-term fertility is actually endangered because the beneficial biological processes are completely disrupted. It's like a short-term sprint that ends up exhausting the track. Section 4, the slow burn, organics, or as I like to call them, the marathon runners. This brings us to a seriously fascinating organic amendment called biochar. It's a carbon-rich material produced through pyrolysis, which is just a fancy word for the high-temperature decomposition of organic biomass. Biochar essentially acts like a microscopic sponge in the dirt. It drastically improves the soil's physical structure, creating highly favorable conditions for plant growth by retaining water and giving microbes a fantastic place to thrive. Now, when you pair that biochar with chicken manure, you get a thriving, vibrant ecosystem. You get happy microbes, locked-in water droplets, and incredibly rich organic matter. The chicken manure brings the nitrogen and phosphorus to the party while the biochar locks it all in. Together, they gradually build up a resilient, ecologically stable soil foundation. They are literally repairing the urban soil over time. But of course, there's a trade-off. Organics require microbial decomposition first. Before a plant can even take a bite, the microbes in the soil have to break that organic matter down. And because of this slower nutrient release, plants just don't get that immediate growth boost. So if you're an urban farmer relying strictly on organics, your short-term crop performance and your speed of yield might really take a hit. Like a marathon runner, it takes a little while to cross the finish line. Section 5, the soil health battle, short-term versus long-term effects. Let's think about this on a timeline. In a matter of days, NPK provides rapid uptake for immediate, visible plant growth. Move out to a few months, and we see the microbial breakdown of organics, like chicken manure, slowly starting to feed the plant. And then, over years, the continued use of organics like biochar builds incredible long-term soil resilience. You're shifting from a quick, instant feeding to serious, long-lasting structural improvement. When we look at the breakdown across the speed of growth and soil health, we have some very clear trade-offs. NPK easily wins the speed race, making it highly attractive for quick urban cycles. However, organics are the undeniable champions when it comes to preserving the health of the soil and drastically reducing nutrient leaching. Which leads us perfectly to Section 6, the ultimate winning combo, integrated nutrient management. So, what's the scientific answer for densely packed places like the Klang Valley? It's integrated nutrient management. This is a beautifully balanced strategy, combining the rapid sprint of inorganic fertilizers with the marathon endurance of organic amendments. The scientifically backed approach here is partial substitution. You don't abandon the chemicals completely, and you don't rely solely on the natural stuff either. You blend them to maximize both your yield and your environmental sustainability. Here is the step-by-step recipe for this awesome tag team approach. Step 1, you apply a reduced amount of NPK to ensure the crops get that early, rapid growth phase they need to actually be economically viable. Step 2, you incorporate biochar into the soil beds to make sure water and those chemical nutrients are retained, not just washed away. And step 3, you use chicken manure to maintain those absolutely essential long-term soil microbes. You get the immediate sprint fully backed by the marathon endurance. And you know what? The results were absolutely stunning. Research confirms that this synergistic mix of organic materials with chemical fertilizers actually maintains or even increases crop yield better over time than using NPK all by itself. It creates true yield stability. The biochar in manure creates such a healthy, vibrant soil environment that the NPK actually works far more efficiently. It really all boils down to this profound takeaway. No single fertilizer type is sufficient to address all agricultural challenges in urban farming systems. Balance is literally everything. You simply cannot cheat the science of the soil. Yes, we absolutely need immediate productivity for the urban farmer, but we also owe it to the ecosystem to build a foundation that's actually going to last. Which leaves us with this final, critical thought. If space in the concrete jungle is our absolute biggest limitation, isn't maximizing both short-term speed and long-term soil health through integrated nutrient management the only true path to securing the food on our plates? As our cities grow denser and denser, understanding exactly what goes into the soil beneath our feet isn't just science anymore, it's survival. Thank you so much for joining me on this explainer today. Keep asking questions and keep exploring the science all around you.